Solving systems of equations. You're going to notice this doesn't have a topic number. It's not a certain section in the book. It's actually several different sections out of the book. It's going to draw on sections, well, I at least know it's in Chapter 3. Some of it's in this chapter, and I think part of it's in Chapter 7. It's a kind of a new SOL, so we're just kind of putting all that stuff together for you. This is something you would have done back in Chapter 3. A linear to linear solution or system, solving a system. Just to give you an idea of what's going on, a system of equations, it's when you have a graph and you have more than one equation at a time. You have one line, then you have a second line, and at some point they're going to cross. All right, so the way to keep this straight, this is the solution where they cross, okay? So you've been hearing me harp on what a solution is for a while. I've been saying it's the same thing as an x-intercept. It's also known as a zero root. That's the case when you have one equation and you're trying to solve it. Okay, if we have one equation, we're solving for x, then that's what's going on. It's x is the x-intercept, which is also a solution, a zero, or a root. They all mean the same thing. The difference here, these are two different lines. So when I'm solving two different lines or a system, I want to know where they cross. So that's what we have. We have a system of equations. If you're looking at what's in front of you here, I've got one method of graphing, one of substitution, and they're both pretty much, actually they are exactly the same thing. They might not look like it at first glance, but they are. And I'll show you what I mean in a moment. Now, let me take you through graphing. We'll use our calculator. If it's already solved for y, there's no point not to use the calculator. So go to y equals, clear out what we got, put your two equations in, 2x plus 5 and negative 1/2 x. Now, a lot of questions come up about this. My advice, put the negative outside the parentheses. If that's confusing, then just put it inside with the 1 or the 2. It really doesn't matter. But the main thing, put fractions in parentheses every time you use them. If you don't, that can mess you up. All right, so there's our two equations. Hit graph. This is going to be real simple. It really is this easy. Okay, they're crossing. Now don't eyeball it. That's the one thing you don't want to do. Use the same method you've been doing. Second trace, intersect. Second trace, 5. All right, one line, the other line, here's the x. Tell it to guess. You don't even have to move anything. Just hit enter 3 times. Negative 2, 1. That's your answer. It coordinates with an xy coordinate. I said that weird. It is an xy coordinate ordered pair. So it's negative 2, 1. That's it. Now, substitution, that's another method you're going to need to use sometimes. All right. Now, I've kind of intentionally rearranged this equation. The first one, if you look close, it really is the same thing. You can do some rearranging and it would be the same thing. But what you want to do, sometimes substitution is the way to go. When you notice that you have one variable solved for, now that you have y right here solved for, but you don't have a variable that's ready to go up on the other equation, I mean, here's y, here's x. Neither one is in the form of x equals or y equals. But down here, you got y equals. So take that negative 1/2 to y equals and substitute it in for y right here. Okay. So let me rewrite how that's going to go. It's negative 2x minus, because I put that negative 1/2 x there, then that replaces y. Okay, it replaces y. That's the substitution. A lot of times students will want to leave the y in here. When you substitute in any kind of ball game, football, basketball, whatever, you don't leave the other player in, you take them out. So y as a player, he came out, he messed up. Negative 1/2 x took his place. That's just how it went. All right, y doesn't get to stay in the game. He's out. Okay, he got substituted. And that's how it works. All right, so solve it like you would any normal equation. 2x minus a negative becomes plus. And if you need to do your fraction rules here, you can make it 2 over 1x plus 1/2 x. We're going to need to change that to a 2, so 4 over 2. 4 and 1's 5, 5 halves x equals -5. All right, the best way to get rid of a fraction is multiply by its reciprocal. Whatever you do on one side, do it to the other. If you need to, well, that's going to cross out. If you need to over here, put that 5 over 1. Those cross out. It's -2 over 1 or just -2. Okay, now hopefully you just noticed something. I knew my answer was supposed to be -2, 1. I got x equals -1. It's tempting to stop right there, but we need to know the point where x and y cross. We had an x and a y. All right, so go back to the beginning. Either one of these two equations, doesn't matter. Pick the one that looks easier, which I'm going to go with the one that says y equals already. All right, and I'm going to substitute again. It's -1/2 x. So instead of x, I'm going to put -2 in its place. And there you go. Multiply those out. Put over 1 if you need to. Those 2's cancel. It's going to be -1. Whoops, sorry. 2 negatives makes positive. +1. Okay. So there's an x, there's a y. That's an ordered pair. That's -2, 1. And that's my solution. Okay. Now substitution looks like it's probably going to take longer. And it's not always the case. Sometimes it's harder to graph than it is to do substitution. It really just depends on the problem. Okay, so we'll move a little quicker after this. That was just to kind of introduce you to both methods. All right, linear to quadratic. Okay, quadratic's a fancy word for parabola. Linear, of course, means line. So we have a line that's going to cross a quadratic. So to give you an illustration, you have a coordinate plane, you have a parabola, you have a line that's going to cross it. Okay? Now, think about this line. If it just touched the corner of that parabola, if it was tangent to it, you'd only have one solution. As it is right now, we have two. And if that line came up a little higher and never crossed the parabola, you'd never have a solution. So you could have no solution, you could have one solution, or you could have two. Most of the time, you're going to have two. Okay, but any of those could happen. Now, what I want to talk to you about is figuring out whether you should graph or do substitution. And really, you need to get good at figuring out which is best. Graphing is easy when you can do it. And the best way to tell is to think about your calculator. Okay? Well, if we're going to use the calculator, it uses y equals. So if we have a y that's pretty easy to get it to y equals form, then it won't be too hard to put it in the calculator. So I'm actually going to rewrite this one over here just for the sake of working it out. There's no other need to do this. I just need more room so I can work down. And that x is squared. The only thing I really need to do is add x squared to both sides. Remember, I can do whatever I want as long as I do it to both sides. So x squared minus 3, that's one equation. I'll put a little dotted box. It's not an answer, it's just the equation. And this one, well, a little bit more stuff. I've got to add y. Really, I guess maybe not too much to do. If I add y over there, that's good. 3x minus 5 here, and well, that's solved for y also. Well, that should be enough to graph now. So pull up your calculator, clear everything out. We have 3x minus 5, and notice I put that in y2. That really doesn't matter. I can put the other one in y1. It's not a big deal. So don't worry about where you put them, and just get both of them in there. Okay. Hit graph. It should be a quadratic crossing a line, or a line crossing a quadratic, however you think about it. This one might be kind of tough to see. It could cross twice. It might just hit it one time. I think it's safe to say it does cross somewhere, though. I don't think this line is off the parabola. We might want to zoom in a little bit, and instead of just hitting zoom, you might want to play with your window. I know that it's between looks like 0 and 3, probably for x. This is happening, and probably between about 3 and -3. I'm just playing around with the window a little bit, but I've got a pretty good idea. That's somewhere in there is about where the crossing is going to happen. Okay. And now that I've zoomed in, I can tell it's crossing twice. Okay, see that little gap right there? If you need to zoom in more, you can, but you can see a gap now. It's crossing twice. There's two solutions, all right? So on my paper, I'm going to put solutions, plural, because it's two. All right, and I'm going to get ready to write two ordered pairs. So second trace, intersect. Now this time you got to get your x pretty close to one of them. Hit enter 3 times. All right, so 1, -2, that's one of them. And then second trace, intersect. This time get your x pretty close to the other. And enter 3 times again. There you go, that's your other one. It's 2, 1. Okay, so two different solutions, and there they are. Okay, so on a graph, just a rough sketch of this thing. You had a parabola that looked something like that. You had a line that crossed it twice. Okay, and that's a very rough sketch, but that's basically what's happening. Okay, you have a better graph on your calculator. Okay, let's do one more of these. This time I haven't told you what it is. Okay, the way you can tell it's a line, x is just plain x, no power. This one's quadratic because x is squared. Okay. Now this one we could probably graph because this one solved for y, this one we could easily solve for y. But let me just go through substitution just to let you practice that. Because this one is solved for y, all right, let's plug that in for y here, see what happens. Okay, so x squared minus, now remember, substitution. We're taking y out of the game, and 3x minus 5 is taken into place. Okay, so a substitution. We're not keeping y in there. Don't ever substitute and keep the same player in or the same number or letter in. This y got substituted, got pulled out. 3x minus 5 is taking its place. I know it seems like I'm saying that over and over, but I've seen it as a mistake way too many times, so I'm trying to help you not make that. Okay, now this is x squared minus 3x plus 5. Look carefully, pause if you need to, but that's a minus. And this is shaping up turning into factoring. You got x squared minus an x, a number. That means you need everything on one side equal to 0. Okay, so again, it just keeps building on itself. Same stuff we've been doing. Just slightly different method every time. Okay, so you do this however you need to. Y'all probably realized I'd prefer this x thing, and I really don't care if you use it or not. Just you factor the best way you know how to. There's nothing out front, so I'm technically dividing these by 1. Doesn't change anything. My two factors are x minus 1 and x minus 2. Now, I think I made this mistake in a video. It's real easy to make. Be sure you put the equal 0 here. Okay, you got your two factors, but that's not what you're doing. You're solving. Solving means you need to have x equals. Okay, so x equals these two things. Okay, we have two solutions. All right, so we know two things that x could equal. Take those back to the top, plug them into either one of these equations, whatever one looks easier to you. I think the first one probably looks easier. It's solve for y, no squaring going on, no powers. So that's where I'm going. I'm going to take 1, and I'm going to plug it in for x up here. So y equals 3 times 1 minus 5. Okay, so I'm not going to spend a lot of time on this. That should be straightforward. That means one of our solutions, if x was 1, y was -2. And the other solution, if x is 2, well, let's see what happens. If we have y equals 3 times 2, substituting into this x, then y equals 6 minus 5, or 1. Okay, so there you go. Turns out that was the same problem as number 2, if you didn't realize that already. Just rearrange so I can show you substitution. Okay, so there you go, two solutions. All right, I'm going to take a break and let you take a break, kind of soak this in. Be sure you watch part 2, but take a minute, make sure this is making sense. You may want to start the practice, and then come back to this.